Osmosis is the tendency of a solvent to flow from an area of low concentration to an area of high concentration through a semi-permeable membrane. In this example, assuming that the left side was just pure solvent and the right side was solvent with some stuff dissolved in it, this would be the semi-permeable membrane. And what the semi-permeable membrane is going to do is that it's going to allow the solvent to pass through, but it won't allow the stuff to pass through. If I take this and leave it there, what I'm going to notice when I come back is that some of the solvent has gone into the right side against gravity. This process is called osmosis. This solvent is going to flow from an area of low concentration to high concentration. It's going to try to reach an equilibrium. And what the osmotic pressure is the amount of pressure that I would have to apply down here in order to get it back to this state. And this stuff is very common in biochemistry and cell biology. The cell wall is a semi-permeable membrane. It allows certain things to go through and other things to stay inside the cell. So what cells often do is use osmosis as a passive transport system for different materials. If you've ever heard of chemical gradients, often what a cell will do is set up a chemical gradient to allow certain molecules to flow in a particular direction, because they'll use this osmosis and they'll go from an area of high concentration to low concentration, or from low concentration to high concentration, depending on how it's set up. And most of this is by using osmosis. And this is also how desalination plants work. If I take salt water and then I apply pressure and I have a semi-permeable membrane here, if this is salt water and I make a semi-permeable membrane, so water will pass but not the salt, then what's going to happen is I'm going to push down here and then water is going to come out of here, but not salt. That's why it's expensive to set up a desalination plant, because people have to contend with osmosis. The water wants to come back this way, so it takes a lot of energy to push all this water down and then have it trying to rush back up in there. That's why it's very expensive. And the last thing I want to talk about is how to calculate the osmotic pressure. This pi symbol is the osmotic pressure, M is molarity, R is the universal gas constant, and T is temperature.